I'm David Spears. I'm the state geologist of Virginia, and as the state geologist of Virginia, some people blame me for the earthquake last summer, but I don't have a good defense, so I'll take partial responsibility. But anyway, I'm the moderator for today's briefing, and the title of the briefing is Faults in the East, the new Madrid Seismic Zone and the recent Virginia earthquake, Understanding Risks. And of course, we're talking about seismic risks. The briefing is presented in cooperation with the Congressional Hazards Caucus, which is a bicameral, bipartisan caucus of congressional members interested in understanding and reducing risks through information gathering and the coordinated efforts of shared national concerns. The caucus is co-chaired by Representatives Zoe Lofgren and Senators Mary Landrieu, Lisa Murkowski, and Ben Nelson. The caucus is supported by the Hazards Caucus Alliance, which is a network, an informal network of about 100 organizations that support the Congressional Hazards Caucus. There is more information about the caucus and the Alliance and the briefings, such as this one, if you go to the Alliance's webpage, which is hazardscaucus.org. The presentations from this briefing will be posted on the webpage afterwards. The sponsors for the briefing are the American Geophysical Union, the American Geosciences Institute, the American Society of Civil Engineers, the Geological Society of America, and the Seismological Society of America. And before I introduce the first speaker, I'd like to say a little bit more about last summer's magnitude 5.8 earthquake that occurred in Central Virginia. And those of us who live, I actually live in Central Virginia in this area that's called the Central Virginia Seismic Zone, and the Central Virginia Seismic Zone is a kind of oval-shaped area between Richmond, Virginia, the state capital, and Charlottesville, Virginia, which some people think of as the state capital, UVA graduates mostly. And so there's this oval-shaped area in there that is defined by a history of small to moderate earthquakes. And so I've lived there about 20 years, and during that time I've felt 2 or 3 small earthquakes, and so we've come, those of us who live there have come to kind of expect earthquakes in that area, but usually they're small earthquakes, and they're certainly not damaging earthquakes. So the event that happened last summer came as a real surprise to all of us. First of all, the initial effects, those of us who were sitting in our offices or in our homes when it happened, my wife was actually in the bathtub and jumped out screaming and ran to the phone and called me and said, "What the bleep was that?" So it was something very, very much different, something that literally shook us from our normal expectations. And so we had the immediate experience of it, but then the day afterward, I had the privilege of visiting the epicentral area with some of our staff at the Department of Mines, Minerals, and Energy, and also some of the scientists from the U.S. Geological Survey. And I think all of us in those first few hours of being out there were really surprised by the amount of damage we saw. There were you've seen a lot of pictures of chimneys that were broken, but we saw houses that were literally shaken off their foundations. And none of us ever expected anything like that to happen here in the eastern United States. But I think one of the lessons we need to learn is that we should expect things like that to happen. And if you look at the history of earthquakes in the eastern United States, there is actually a pretty long history of damaging earthquakes, going back to I was looking yesterday, 1755, before Massachusetts was even a state. At Cape Ann, there was a 5.9 magnitude earthquake that actually caused a tsunami, and that tsunami came on shore and swamped part of the Massachusetts Bay Colony. So 1755, a 5.9 earthquake that was bigger than the Virginia earthquake, which is 5.8. Of course, the biggest earthquake ever experienced in the eastern United States was the swarm of earthquakes that occurred 1811, 1812 in New Madrid, which at the time was part of the Louisiana territories, now in the state of Missouri. And that was 3 earthquakes over a period of a couple months, all of which were over 7.0. Some people say, of course, we didn't have good instrumentation back then. Some of them may have been as much as 8.0. So these were really, really large and damaging earthquakes. 1886, Charleston, South Carolina, 7.3. Really large earthquake for the eastern U.S. The earthquake last summer was not even the biggest earthquake Virginia's ever experienced. We had a 5.9 in 1897. There was a 5.5 New Hampshire. 1940, 1944, 5.8 in New York, and then, of course, 2011, the 5.8 in Louisa County, Virginia. So what my point here is that if you take all those earthquakes and average them out over that time period, that's one damaging earthquake every 30 years or so in the eastern U.S. And so it's something that we should expect, but 30 years is about long enough for most of us to forget. But we really shouldn't be forgetting. We should be remembering that this is a hazard, and we should be doing something about it. So I hope that the work we do here today will help us as a nation and as the eastern states to take some steps toward reducing the risks that these earthquakes cause. So we have 3 speakers today, and I'm going to introduce the first speaker, who is Wright Horton, who's a research geologist from the U.S. Geological Survey in Reston, Virginia, just a few miles to the west of here. The title of his talk is Learning from the 2011 Virginia Earthquake.
This information is publicly available from USGS websites and other websites as noted on the slides. The photo is from the National Cathedral showing some damage there. Where do most large earthquakes occur? At Earth's tectonic plate boundaries. And one plate boundary of special interest is the boundary between the North American plate and the Pacific plate that follows the west coast of the United States. But Virginia is not on a plate boundary, and neither is New Madrid, the subject of the next presentation. Intraplate earthquakes within plates, are less frequent and less well understood. Here's a map of one of the seismic hazard maps. This is not the most recent one, to make a point. This one was prepared in 1996, and all of the earthquakes shown as stars on this map occurred after the map was made. So this illustrates the predictive value of the seismic hazard maps, which continue to evolve and improve. In the eastern United States, you see the New Madrid Seismic Zone, Eastern Tennessee Seismic Zone, Charleston, South Carolina Seismic Zone, a little bullseye in Central Virginia for the Central Virginia Seismic Zone, where the magnitude 5.8 earthquake in August was the largest earthquake known to occur. There have been other significant earthquakes. Here's some of the others that have been known to occur in the east over recent history. So you see New Madrid, Charleston, etc., and the recent 5.8 in Virginia. Zooming in a little closer, the Central Virginia Seismic Zone is, this is just an oval drawn around earthquakes that have occurred historically. It's not well defined otherwise. The recent earthquake is shown by a star and is within that zone. And it's the largest one known to have occurred in the Central Virginia Seismic Zone. The earthquake was not a surprise in the sense that it occurred in a well-defined seismic zone that's been identified on hazard maps, several generations of hazard maps. But it's a wake-up call for the East nonetheless. This is a Did You Feel It map. The USGS has a website where people can log in with their experiences. Each of those dots on the map is a person who filled out a form indicating their experience. So this earthquake in Virginia was felt from northern Florida to southern Canada as far west as Missouri. It's the most widely felt earthquake since the website came online. Based on the population and the number of zip code areas, we believe it affected about a third of the people, was felt by about a third of the people in the United States, making it the most felt earthquake in U.S. history. It's the largest in Virginia in 114 years. There was one of similar magnitude about that time ago, as David mentioned. Fortunately, it occurred in a low population area, so there were no fatalities, although the damage is in excess of $100 million. This is a comparison of the Did You Feel It map. Each dot, if some of you filled out that web form, one of these dots may be yours, showing how much, and a similar magnitude earthquake in California, just to illustrate the point that earthquakes in the east are felt over a much larger area than those in the west. So in addition to affecting a larger population in the northeast urban corridor, the energy of the earthquake is transmitted over much larger distances. Moving close to the epicenter of the earthquake in Louisa County, you'll see a lot of the damage to foundations of houses and buildings, bricks, chimneys, that sort of thing. One of the people on one of the residential streets who noticed that the houses made of wood were standing while the brick houses were looking like this, wanted to rewrite the story of the three little pigs, with the brick house being the weaker one. Moving north about 11 miles to the North Anna Nuclear Power Plant. This is the first operating nuclear plant in the United States to shut down because of an earthquake. It was shut down automatically and remained shut down for 2.5 months. The design basis earthquake for this plant is shown by the pale green bars on the diagram on the right. So the shaking, or the ground acceleration, actually exceeded the ground basis where those blips go outside the green bar. Then moving 100 miles north of the epicenter here in Washington, D.C., we have damage to prominent structures like the Washington Monument, National Cathedral, Smithsonian Castle. And this is just a reminder that to those of us in the East that the East is vulnerable to earthquakes. This is another thing generated automatically by one of the USGS websites. It's called a shake map that instantly reports shaking intensity from the earthquake. Areas where there was perceived shaking was severe or very strong were fortunately limited to this rural area. But what if that earthquake had occurred in Richmond, which is also in the Central Virginia Seismic Zone? An analogous event would be the earthquake that affected Christchurch, New Zealand, similar magnitude, where there were 184 deaths and billions of dollars in damage. Immediately after the earthquake occurred, a number of organizations, shown by different colored triangles, installed seismic instruments in the vicinity of the earthquake, and some of the first aftershocks are shown in this diagram. As a result, the earliest large aftershock within 24 hours was recorded by the first 8 instruments installed, and this has resulted in the best recorded aftershock sequence ever in the eastern United States. Here we see the instruments that are still in place. The USGS instruments are in green and the others are in blue. Most of the other stations have been removed. The aftershocks are the red dots. Just this month, a LiDAR survey was flown. This is shooting lasers out of airplanes to make very precise measurements of the ground surface to look for more subtle effects on the ground. Here we see a calendar starting with the magnitude 5-point earthquake. The horizontal axis is a calendar going to present. Most of the aftershocks were most abundant in the month or so immediately after the earthquake and begin to decrease. So since about January, there have been fewer, but we still, just within the last week or so, March 25th, had one that exceeded magnitude 3. Plotting the aftershock locations on a Google map image, the colors show depth, so that the blues are 6 or 7 kilometers deep. Let's say the yellows and greens are intermediate depths of 3 or 4 kilometers. The reds are shallower, 1 to 2 kilometers. So we see that this is imaging a fault plane that's dipping toward the southeast with 7 kilometers, 5, becoming shallower over here, and we can predict where this would project to the surface and look for evidence on the ground. To look at the same aftershocks in a cross-section view, the aftershocks actually image the fault. This is the first time in the eastern U.S., at least east of New Madrid, Missouri, where we've been able to actually image the causative fault of an earthquake. Showing the position, recalculated position of the main earthquake on the aftershock plane. The evidence from the main earthquake indicates that the southeast side moved up about 2 kilometers relative to the other side, focusing energy toward the surface. The earthquake, well, here's a map of a lot of earthquakes in the Central Virginia Seismic Zone. The squares show that they don't correlate easily to known faults in the area. Some of the old faults, which are there from earlier events in the geologic history, are lengthy. Big earthquakes occur on big faults. There are big faults here, but they're old faults. The question is whether any of these old faults can be reactivated. If so, there's a potential for a larger earthquake than 5.8. And more detailed geologic mapping is underway in the area now to map these faults in more detail and try to connect them with the earthquake. So what are we learning? The big earthquakes in the central and eastern U.S. are rare, but their impact can be large. The earthquake struck a known seismically active area. There are large faults, but there's much uncertainty about which of these old faults are active. Seismic energy in the east travels long distances, and communities in the east are relatively unprepared compared to those in places like California. Other things we're learning: there was a high stress drop immediately after an event. This is the difference in stress across the fault before and after the earthquake. The significance of this we're not sure of, but it may be something unique to eastern earthquakes. The angle of the fault, as we imaged, directed energy to the surface. There's no confirmed surface rupture yet, although there's some possibilities, and the LIDAR survey results may be able to help us locate some more subtle features. So the fault, while we've imaged the fault that's causing the earthquake, we have not yet tied it to the older faults. Fundamentally, we still don't know the cause of earthquakes in this part of the country. Other things we're learning: the old brick buildings perform poorly. The recorded ground motions from this earthquake will help to constrain potential damage and ground motion from future earthquakes. There's some new opportunities to adopt. There's an NSF program of seismic stations migrating eastward across the country, and called Earthscope. There's this transportable array of seismic stations, and there are opportunities to adopt some of these stations as permanent stations in the east, which would greatly strengthen the network there. More information is available on these websites from the USGS, and I'd like to thank all of the people listed who helped with the presentation. Thank you.
Good morning, everybody. Here it is. Let me take you back in time here. I'm going to talk about the 1811, 1812 earthquakes. And this occurred 200 years ago, these earthquakes. And it's almost inconceivable to imagine what would happen today if those earthquakes occurred in the present situation. 200 years ago, there was a doctor in Louisville, Kentucky. I think you can see the dot on the map there. He was about 300 miles from the earthquake epicenters. And he rigged up, because he kept on feeling earthquakes, he rigged up a bunch of springs and masses. He had them in his house all over the place. And when he felt an earthquake, he'd go look at these things bouncing around. And he'd record the time. I'm not sure how good of time they had, but he recorded these things, and he made a list of these earthquakes. And he recorded at least 1,000 earthquakes, more than 1,000 earthquakes that they felt in Louisville, Kentucky. And 200 years ago today, I looked at his list on March 29th. He really didn't, there was some small tremor. The day before, there was something that people felt. And after that, I think he basically stopped doing it and probably got tired of looking at these things so much. But he was kind of the first American seismologist, in a sense, to actually record all these earthquakes. Now, here is a list of earthquakes that occurred in that earthquake sequence. Starting in December 16th, 1811, there was roughly a magnitude 7.9. Now, these numbers are not very accurate. I mean, the estimates go from 7 to 8, and so we don't know exactly what the magnitude is, but they did amazing damage to the natural surroundings. And you can see that there are 12 or 13 earthquakes that are bigger than the recent Virginia earthquakes, occurring within a span of 2 months. One earthquake that large is bad enough. They had 3 earthquakes. The damage was very extensive to the river. Banks caved in. There's no mention of people being lost, but the Indian population moved on. New Madrid was terrorized. The town of Little Prairie, Missouri, was basically sunk, and people fled to the hills as fast as they could. So it was a very striking geological event. Now, if you look at the earthquakes that we observe today, all that the clouds of black dots on the screen are we record something like 200 earthquakes in New Madrid Seismic Zone per year, located, and we think these earthquakes delineate faults that actually broke in that earthquake sequence back then. So there's a sequence of these 3 large earthquakes and then very large aftershocks associated with all that. Not only did they make these faults break, but there was large areas of land that was uplifted and in fact served as a place on the river. That's why New Madrid was there, because it was higher than the surrounding swamps, and so that was a place to settle. But it uplifted this area even larger and is a direct manifestation of the faulting that occurred there. Now, most of the stuff that we know about these earthquakes occur from some written accounts. The bells rang in where? You've heard Boston, right? It's wrong. They rang in Charleston, South Carolina. It was reported in the paper in Boston. Actually, the congressional record actually is mistaken reference for this happening, but they actually ran in Charleston, South Carolina. Still, that was on the coast, long way away. But most of what we know technically about these earthquakes come from the geologists who look at what's called paleoseismic evidence, and you see that these in this area, there's vast regions, thousands of square miles, where the land actually erupted in sand volcanoes and what are called sand blows, where high pressure, the waves created shaking, pressurized the ground, the stuff spewed out, and water and sand and you name it came out of the ground. This is actually a picture of a New Madrid sand blow taken in 1912 by USGS geologist Fuller that was still there at the time. And so these sand blows actually give you information about past earthquakes. The geologists have found from stratigraphic analysis, the sand comes out, river sediments bury that sand, it builds up, more sand comes out in the next earthquake, and you can actually date all this stuff. And it turns out that there are 4 distinct sequences of earthquakes: 1811, 1812, 1450, similar sequence of earthquakes, 900 AD, and 2350 BC. And what's distinctive about these things is that there were several earthquakes associated in a short amount of time, because you have sand blow on top of sand blow after all these earthquakes. And so the amount of shaking was probably comparable to 1811, 1812 in these past earthquakes. So there's our history of earthquakes in the central U.S., and there's no reason to suspect that it's going to quit. Well, all this information goes into the USGS hazards map. Here's a view of that map on a Google Earth type of presentation. The red area is the region of high hazard, and you can see the bullseye for the New Madrid seismic zone in the central U.S. This is actually a combination of where do the big earthquakes occur and how much do they shake. The central and eastern U.S. area actually is shaken very easily by an earthquake compared to the area in California. The waves propagate much easier in this crust, and so the hazard rises up because of that. Here's another view of it. New Madrid. This is an estimate of one of the estimates of the magnitude of the December 16th event, 1811. It was felt over most of the country at that time. And here's a similar size event in California in 1992, which certainly those seismic waves and perception of shaking didn't go as far. So we have kind of a special thing in the eastern United States where the waves just travel very easily and people feel them, as Wright Horton pointed out for the Virginia earthquake. Well, one way for us to learn about this, the wave propagation, how much shaking can occur, is through the Advanced National Seismic System, ANSS. And here's what it looks like. The University of Memphis in Siri sits right there in this, right here at the edge of this bullseye. It's New Madrid, Charleston seismic zones. And all these little dots are the seismic stations that we put out to actually record earthquakes that occur. And you can see this, the seismic stations are concentrated to where the earthquakes are. Here's another way of looking at it. If we look at the earthquakes, the clouds of little brown dots and red dots on the map, here's New Madrid. Here is the Eastern Tennessee seismic zone. It's another prominent zone in Tennessee. New Madrid has like 200 earthquakes per year. Eastern Tennessee has roughly 100 that are located by this network. And all these particular symbols denote critical facilities like nuclear power plants, squares, fossil fuel plants, the triangles, and dams along the rivers. And not so much in the New Madrid area, although the dams are concentrated over here, but there are a lot of power plants in the Eastern Tennessee seismic zone. So like the seismic stations, it seems like critical facilities are attracted to earthquakes. So here are the odds. You put all that stuff together, where the earthquakes are, how much they, how long do they, what are the interval between these earthquake sequences. And in the New Madrid area, there's a magnitude 6 or greater event. You have a 15 or 40% chance of that happening in the next 50 years. For a New Madrid type large earthquake, there's a 7 to 10% chance. Now, these things are calculated, if you imagine you got 5 boxes of 50 years long, and you just go on the other side of the room and throw something into one of those boxes and say that's when the earthquake is going to occur. That's how those chances are figured out. And so we have 5 boxes to work from one earthquake to the next in 50-year intervals, 500-year return period, and basically that's our chance. Now, there is a controversy. You may have heard about it. Very prominent, thank you, seismologists think that the New Madrid system is shut down because of global positioning system data doesn't seem to show any deformation in the area. But GPS models or GPS data depend on a model to understand the ground motions that you observe. And this got so much press that the National Earthquake Prediction and Evaluation Council presented or suggested that a panel be formed to evaluate this particular kind of unprediction, the prediction that an earthquake will not occur ever again, and concluded from lots of testimony and sifting through the facts that this conclusion that there's no reason to believe that the hazard has been reduced in that area. We have earthquakes, we have this history, and we don't understand GPS yet. Well, Wright talked about why earthquakes, just a couple things about the science. In New Madrid, there are scars that are underneath the ground. The area is covered by thick sediments, but there is a 500-million-year-old rift zone, the Reelfoot Rift, that seems to be reactivating to cause these earthquakes. And basically, if we let the rift keep on going, 500 million years ago, we would have an ocean. There is no ocean, so it stopped. But all those faults are still there, and that's what's being reactivated today. Now, one of the things that you should be aware of is that there's a large National Science Foundation experiment called Earthscope that's sending 400 seismic stations across the country, like this giant caterpillar. So the stations started in the west. They take the western stations and put them in the east, and it's just kind of creeping across from California to the east coast. Right now, in the white area is where they are. This is as of yesterday. I got this off the website. And it's right in the center of the country. We're using these stations to analyze the structure of the crust and the mantle to figure out why these earthquakes are occurring, because it really is a conundrum. And this is just an advertisement for one of the projects that I'm involved with. 4 universities have put together a project under Earthscope to look at this area and to address these kinds of problems. Thank you. And this is a picture of Reelfoot Lake. These are bald cypress trees, and all the knobs that come out of the water are part of the root system of these trees. Reelfoot Lake formed in 1812, February 7th, when that fault scarp popped up and dammed up Reelfoot Creek. And you can actually find in the older trees 2 levels of these knobs where they used to be and where they are now, because everything came down and the water level came up. So, thank you.
All right, so you've heard from the science, and a lot of what I'm going to talk about directly relates to not only the central U.S. but the eastern U.S. So a lot of my emphasis on the infrastructure and buildings, you can relate that to both the central and eastern U.S. So what I'm going to talk about today is a little bit about understanding the risk. What is it we face? What do the models say that the risk is, the numbers that are being generated, looking at that vulnerability. We're going to look at the effort that's underway to address that, the planning that we're doing to reduce that vulnerability, both in the response, recovery, and the mitigation areas. And then finally, some of the planning challenges that we face in an area of the country that really, earthquakes is not the first thing you think of when you talk about earthquakes. It's more of a West Coast issue. I use this a lot in a lot of my presentations because I think it really helps set the point for what we're up against. These are images that either I've taken or have collected from around the central U.S. of things that have gone wrong on a daily basis. Retaining walls, landslides. Some of this stuff is tied to our interstate systems. So these are problems that we're seeing every day without the shaking. What that means is we have a lot of old buildings, old infrastructure in the central and eastern U.S., dating back to the late 1800s, and some of it even older, probably on the East Coast. And very little of it has been retrofitted for earthquakes. And that's problematic. My friends on the West Coast it's kind of a joke, don't like me to say it, but they've had the luxury of earthquakes to knock down their old buildings. They've built back. They have stronger codes. They have a better understanding of what that risk is. We haven't had that in the central and eastern U.S., thankfully. But we know, based on the science, that our day is coming. And whether it's today or 50 years from now, it's going to happen. And these are the structures that you're going to see causing the most problems. Thankfully, that we do have codes in place now that are reducing that vulnerability, but we still rely on a lot of old buildings. The other piece of this is we have a lot of communities that are very small to the very large. Typically, when you think about an earthquake impact, you think about California, LA, or San Francisco, or something like that. We have Memphis and St. Louis. Those are our 2 largest communities. And then everything else is in these small communities scattered in between. And I'll give you some numbers on that here. We have about 7 million people at most direct risk from a major earthquake in the central U.S. When you look at the numbers and you divide out or subtract out Memphis and St. Louis, which represent about 1.5 million each, respectively, the balance, that 5 to 6 million people, are scattered in these little communities throughout the central U.S. This is unlike earthquakes you see in California or Seattle or Alaska, where they impact a relatively small area, a community itself. The complexity that we face here in the central U.S. is it's a multi-state impact. And you saw this in the first presentation with the Virginia earthquake and the widespread felt impacts of the earthquake of last year. Same thing here in the central U.S. It is the geology that dictates how the waves propagate and the impact that we would expect. So for areas where you have a lot of unreinforced masonry buildings, you have old cast iron pipes in the ground, you have all these things that have been there for 50, 60, 100 years, that's the problems that we're going to see in the earthquake, on top of the fact it's spread over a very large area. And that's what my organization was established to try to coordinate. These are the numbers that were generated from a 7.7 earthquake. This is a magnitude that was given to us by the USGS as a recommended high-end event to model and to plan against. We as emergency managers, we do plan for the worst case, unlike engineers and others who may make decisions based on smaller magnitude events. We have to look at the worst case. So what you're looking at are the numbers, which may be a little hard to read for where you're sitting, but this was generated using a modeling system developed by FEMA called HAZUS, it just stands for Hazard US, based on a 7.7 centrally located on the central fault of the 3 faults, or the 3 arms that Dr. Langston spoke of. So as you can see, these are very high numbers. These are, 700,000 buildings damaged, over 2 million people in outages. And this one is really, I think, the one that makes a telling picture. That's billions. That's close to $300 billion loss from an earthquake. Katrina was somewhere between 100 to 200 billion. So we're exceeding that by at least 100 billion from this event. And again, this is just modeled. It could be higher, it could be a little lower, but these are the best estimates that we have based on the models we have. So this is a significant problem with a significant impact to not only the Central U.S., but the surrounding, the country at large. So based on the fact that we have old infrastructure, we have a unique hazard because of the way it affects the large area, unlike other areas, we have a real problem. And so I'm going to spend the next few minutes talking about what we're doing to address that and the importance of the partnership that's necessary to do this. I am with the Central United States Earthquake Consortium. This is headquartered in Memphis, Tennessee. It's a nonprofit organization that was stood up in 1983 in partnership with FEMA, which at that time was a very young agency. FEMA was just stood up in '79. So in partnership with FEMA, we have operated in the Central U.S. in looking at how we address the seismic risk. We're a very small organization. There's only 5 of us on staff. We have 18 states that we represent. 8 of those make up my board of directors. The states of Alabama, Arkansas, Kentucky, Illinois, Indiana, Missouri, and Tennessee are the core states that we represent. Some of the members on this caucus are members of this organization. But what we do as an organization is very dependent on the science community, the engineering community, the private sector. This is, as you can tell, a very large problem that not any one agency or any one organization can address by itself. So it's through this mechanism, through CUSEC, that we're able to reach out and build the partnerships that are necessary to address this hazard. We have 4 FEMA regions that fall in our area, regions 4, 5, 6, and 7. So again, you begin to see the complexity of dealing with something like this when you've got this many entities trying to be at the table to put together plans necessary to respond, recover, and mitigate against. Just a quick map to show you the area we cover. The darker green, I guess they're supposed to be blue, but the darker green states are the core member states that are most directly impacted by a new Madrid event. These are the states that were modeled for the previous slide. The lighter shade green are our associate states, the other 10 states. Basically, those states are in place to bring aid and support to the impact states. The other states that you see in color in red and gray are the other NEHRP-supported consortia in the country. There's 4 of us altogether. 3 of us are direct relationship with the State Emergency Management, and the 4th one, the Cascadia Earthquake Group up in Seattle, is a public-private partnership to look at building better relationships there. So pretty much every state in the United States is covered under one of these organizations. The states you see in white typically are lower seismicity and don't have a high percentage of earthquakes. There is some interest in Florida and some others in coming on board, but right now this is what the states are covered under these consortia. This is how the earthquake program works in the Central U.S. on the emergency management side. I have a board of directors. These are the state emergency management directors of each of these 8 states. Each of those states has an earthquake program person assigned to address the earthquake hazard in that state, or the risk in that state. And they put a work plan together each year that defines what it is they're doing in 4 areas: public awareness and education, mitigation, response recovery, and the application of research. Those same 4 areas are the goal areas within my organization, CUSEC, which is on your right side, where we're the regional earthquake program. So these state directors make up my board of directors. So you can see the connection here very closely between the state emergency management and what we do, and then working through that system to reach out to all the other groups that are important to addressing this hazard. And this is just a very short list of those partners that we have. You'll see Dr. Langston's group, the Center for Earthquake Research and Information on the list. There's other groups that are in the Central U.S. and outside the Central U.S. And again, this is very important to addressing a hazard that is so much beyond our capabilities as one entity to address. There's many more people that, and organizations that are on this list, but this is just a quick sampling of the folks we work with directly day in and day out. I mentioned the 4 goal areas that we operate under: public awareness and education, mitigation, response to recovery, and the application of research. So these are sample activities under these areas that I wanted to share with you. Mitigation is the cornerstone of what we try to do. We want to reduce that vulnerability so that we're not having to respond. But we got a lot of old stuff. It's going to take a long time and a lot of money to reduce that vulnerability. But it is important, and it is a major goal of our organization. Our number one goal is public awareness and education. We're in an area of the country that really doesn't understand earthquakes, why we have earthquakes. So it's very important that we continue to push good information out about the threat and information about counter theories about what the threat might or might not be, to continually give people the information that they can make the best decisions on. We do that through a number of activities, public awareness activities such as town hall meetings, briefings like this, information that we produce, brochures. And one of the things we've been doing for the last 2 years, which has been a tremendous success, is the Great Central U.S. Shakeout. This is an activity that started in California, and we adopted it for the Central U.S. Our first year, last year that we did it, we had over 3 million people participate. Despite the tornadoes and the floods that were going on, this was a tremendous first shot for us. This year we changed the dates and rearranged some things to correspond with the Earthquake Awareness Month, which is basically February for us. And we had about 2.5 million. So we didn't quite make the same mark we had the year before, but it's been a very big success. USGS is a major partner in this, our state geological surveys, as well as the private sector. We received an award for this activity last year from the White House, the Champions of Change program. So we're very proud of that. We're also rewarded by FEMA for our efforts in the individual and community preparedness. Both of those given at the same time about 2 months ago. So we're very excited about that program. It's something that will continue. Hopefully we'll continue to build on this. A response recovery, clearly you got to have plans. You got to be ready for when the event takes place, and then be able to recover. We have a good handle on response. We're pretty good at responding in this country. We know what needs to take place. The challenge that we face is the complexity of dealing with all these jurisdictions and bringing these plans together. So that's an area that we're working on. I'll talk about that a little bit more in a minute. And then the research. We're not a research entity. Again, we're emergency managers. We take the information that's developed in the research community and make it applicable to what we do. There are some areas that we work, if you want to call it research. We have an association with state geologists. They've been working to develop soils maps. Again, these are the products that we can put into our models to improve our models. But for the most part, we take the information that's developed by USGS and others to apply it to the planning and the outreach that we do. Some of the challenges that we face, I've mentioned the complexity of so many jurisdictions that are in the Central U.S., but bringing the public, the private sector together. We say it's easy to think about, but there's a lot of challenges there. The private sector thinks differently than the public sector. The timescales in which we operate are different. So that's a major area that we're focusing on. We have a workshop coming up in August specifically targeting that issue. I mentioned planning integration, local plans, state plans, regional plans. And one of the things we found out in the last few years is that the scientific community has plans to respond which weren't tied into our plans on emergency management. So we're working to close these gaps, but there are challenges that remain that we have to focus on. The tough nut to crack, if you will, is recovery. This nation doesn't have a law in place that dictates how we recover. We have laws that determine how we respond, the Stafford Act and others, but there's really nothing in place that defines how we recover from a major event. There's not a defined agency. There's not FEMA that's defined or whoever defined to be the recovery agency. HUD does a lot of it. Small Business Administration does a lot of it. FEMA does some of it. And this is problematic at the state level as well as the national level. So we're working very hard and very close with FEMA, who just released the National Disaster Framework, part of the Presidential Directive 8 to develop a series of frameworks for mitigation, response, recovery, mitigation, to focus on this more intently. So we got a lot of work to do in this area. One of the things that you can help us with, and I don't know how many committee members might be on the committee that oversees the reauthorization of NEHRP, but NEHRP was last authorized in 2004. Its authorization ran out in 2009 and still remains unauthorized. There are a couple versions, a House version and a Senate version floating out there. We're on record as not liking some of the verbiage that is in there with the emergency management piece, but it is necessary. We need to get that thing reauthorized in order for the program to move forward. And so that's one of the areas that we're working with our National Emergency Management Association to promote, obviously supporting USGS and others that are tied into this bill. So we'd like to see that reauthorized as quickly as possible. And finally, where we're heading as an organization, continue to work in those 4 goal areas I mentioned. We just came out of a major exercise and 5-year planning initiative with FEMA, and we're taking the lessons learned and the shortfalls out of that and folding them into our next sort of a timeline. These are the multi-state areas that we're addressing, culminating in an exercise 3rd week of June, June 14, called Capstone 14. So again, we're not just sitting on our laurels. We're trying to continue to push and be as prepared as we can be in the central U.S. And the same holds for the eastern U.S. So as you've heard from the science, as you've heard from what I've said about the risk, the stage is set. We are truly sitting on a catastrophic event should it happen. And again, that's not just the central U.S. I think the eastern U.S. too, should they have a larger event. The central U.S. is the crossroads of America. You've got FedEx, you've got UPS, you've got major warehousing, Mississippi River, the Ohio River, the Missouri River. Everything can go wrong is right there in the central U.S., and it would be a national, if not an international impact. So, we're very concerned about that, and we continually reaching out to others to help us address that. We have low-level understanding of the hazard, and of course, everybody wants to talk about funding. So funding is always an issue. But I don't want to leave you thinking that it's all gloom and doom. We are making progress. We are changing the way in which we build. We have the latest building codes in most of our jurisdictions. We're retrofitting existing structures, and we're planning and preparing for the event. So not all is lost. We're getting there, but it is still a significant problem that we face. My contact information, and I think that's it.
All right, thank you, Jim.